Hello everyone. In this session, we are going to discuss a very important law in current electricity, which is called Ohm's law. So before start Ohm's law, we will talk about some day-to-day experience. So we know that we are always keeping the tank on the terrace, and from the tank we attach the pipe, and this will get tapped. This will get tapped. The question is, why we are always keeping the tank at some height from the ground level? Because as you keep some height from the ground level, then what happens? The rate of flow of the speed of the water will increase. As we increase the height, the rate of flow of the water through the pipe also will increase. Suppose if there is any damages in the pipe, definitely there will be leakage. If there is a leakage in the pipe, then what happens? The flow of the speed through the tank will decrease. The speed will decrease. So please notice, as we increase the height of the tank, the flow of the speed of the water will increase. But if there is any leakages in the pipe, the flow of the speed of the water will decrease. The same method I am going to apply in the electricity, current electricity. So we have a conductor. Just imagine we have a conductor. So this conductor has two ends, and one end is called A and this called is a B. So is it clear? So the two end of the connector, it is attached with the battery, and positive, negative, this will be direction of current. So point A will have some potential, point B will have some potential. For example, point A will have a 10 voltage, point B will have a 2 voltage. The difference is 8. Is that clear? Suppose the point B, keeping the A always 10, suppose if we keep the B value as 3, the potential difference will be 7. Is that clear? So suppose if we keep 0, the potential difference will be 10. So please notice, we can change the potential difference by adjusting the level of battery. If you adjust the battery level, then what happens? The potential difference across the two ends of the conductor also will be changed. Is that clear? So that is the thing they are trying to tell us. So from this, we are going to increase the potential difference across the two ends of the conductor. Then what about the flow of charges in the conductor? So what they are telling, when you increase the potential difference across the two ends of the conductor, the rate of flow of charges will increase, and because of that, the current in the conductor also will increase. As we increase the potential difference across the two ends of the conductor, the rate of flow of the speed of the charge will increase, and because of that, the current will increase. The same way here, if we increase the height of the tank, the flow of the speed of the water will increase. Is that clear? So according to Ohm's law, the potential difference, if we increase the potential difference across the two ends of the conductor, the current in the conductor also will increase. And this law we are using at only what? A constant temperature. At constant temperature. Is that clear? So I can give the mathematical relations between V and V directly proportional to I. As we increase the potential difference across the two ends of the conductor, the flow of current in the conductor also will increase. And if you want to cancel the proportional, we have to add some constant, that is V is equal to R into I. What is by R? That is called resistance. If we increase the V, I will increase. If we decrease the V, I will increase. Then what about R? It remains unchanged. It remains unchanged. I can give R equal to V by I. And we know that the voltage unit is volt, current unit is ampere, and the resistance unit is called ohm. The symbol is, this one is the symbol. So what is mean by resistance? Resistance, it always opposes the rate of flow of charges, like a leakage. Leakage is called resistance. So when the leakage increases, the water coming out through the pipe, the speed, it will decreases. So and also you just see the speed break in the road. So maybe the vehicle comes with greater speed, but when it comes very closer to the speed break, the speed has to decrease. So like that, So the resistance, it always opposes the rate of flow of charges. If you oppose the rate of flow of charges, then what happen? The current will decreases. I can say I is indirectly proportional to R. Is that clear? So when you increase the R, then what happens? The I will decreases. When you decrease the R, the I will decreases. Is that clear? So from this we can say that V directly proportional to I. Please note this, in current electricity, the current will not exist by own. It is exist because of voltage. When there is a potential difference, current will be there. When there is no potential difference, current will not be there. That is zero. Is that clear? So the I is because of V. Is that clear? So simply we can say that V is independent of I, but I is dependent on V. Because when there is a potential difference, there will be current. You just see that when there is a tank, if the tank and the pipe are the same level, there is no flow of water. Is that clear? Which means the speed will not increase, it will not decreases. Is that clear? As we increase the height, so we can say that the flow of the speed coming out through the pipe depends on the height, the pressure variations. Is that clear? Like that. So the current in the conductor depends on only potential difference. Is that clear? So finally we can say that according to Ohm's law, at constant temperature, the potential difference across the conductor is increased. The flow of current in the conductor also will increase. So and also we can say that the resistance is independent of V and I. The resistance will depend on some other factors, and that factors we will discuss on the next sessions. Thank you.